Shall we proceed? Okay, so I hope I'm audible. My screen is visible.
Yes, sir.
Good. So you're talking about the parallel processing before the break, right? I hope you understood the overall concept, why we need to talk about it. Simple program will never make use of the multiple processors or multiple cores available with your processor. And if we want to utilize that, one way is to do some low level, hardware level, system level programming. The other way is to make use of some of the library functionality made available by the platform. Thankfully, .NET platform comes up with the support for parallel programming already. And that is available in the form of out of the box features provided by the task parallel library. This is something which was introduced in .NET framework since .NET 4, where a new CLR was also introduced by the version CLR 4.0, where CLR, is the common language runtime for .NET. And for .NET Core also, we do have this support. And for .NET Core, the CLR version is .NET Core CLR instead of just .NET CLR. So conceptually, the things remain the same. And here we need to understand exactly how task parallel library or TPL can be used. It's a part of the base class library itself. We don't need to add any reference or anything as such. Okay. Okay, so let's proceed. Let's take a new project over here. It has to be a console application. So select console in the last drop down. And here, as we said, we will be using .NET Core here onwards. So console application, the first one template we are going to use. The one with all these tags, C#, Linux, Mac OS, Windows, console, etc. Okay, let's say next. Let's name this as CS underscore demo task parallelism. Make sure you are in the correct path and say next. CS underscore demo task parallelism is the name that I've chosen. Next. .NET 5 is what we'll be going with. Let's say create. Okay. So to understand the worth of the parallel program, what we will do is we'll start with a non-parallel program first of all. Okay.
Yes, sir.
Set of threads we will be using. So import the namespace named as system.threading. Let's create a class over here by the name my class. Just before class program. Create a helper function. Private I enumerable. I enumerable comes from another namespace that is system.collections.generic. I want this function to return a list of integers. So I say I enumerable int. I name this function as getData. The kind of code I'm going to write into this function is going to execute quite fast. To simulate that, it takes a while to get finished, to get the data ready. Here I'm using thread.sleep function. This is just for simulation that it's a long running operation, which says that around, little over 10 seconds it is going to take. This is 10,000 milliseconds. Okay. So when I convert milliseconds to seconds, it is 10 seconds only. And then I say return enumerable. There's a class called as enumerable that comes from another namespace. System.link. There is a function, static function called as range provided by this class that takes in a start number and total number of numbers that we want. Let's say 10,000 numbers is what I want. Generates a enumerated list based on this input. So practically it will give me a list which contains the numbers from 1 to 10,000. Okay. This is usually quite fast. That's why I use this statement. If your code is by default taking a lot of time to get processed, in that case, thread.sleep is not required. What it means is in the real-time applications, we will never be using this thread.sleep in the functions which return the data. Understand? Understand?
Yes, sir.
Okay. Now here I create another function. which returns an enumerable of int named as get numbers list. This is actually going to be a wrapper on my previous helper function, or else I can just make this itself accessible by using the access modifier as public instead of private. So for now, here I say return get data. Okay. Okay.
Yes.
Now let's go to main. Create an instance of my class. Like this, my class m equals to new my class. This is a console application, so the end user must be informed at times. So here I say console.writeLine, invoking get numbers list function. Here I say where data equals m dot get numbers list. What will be the data type of this variable data? It's enumerable of int because my function get numbers list is having return type of enumerable of int, right? There I say console.writeLine /n per couple of new lines. Get numbers list function finish. Then I say console.writeLine an interpolated string number of values in the collection to be displayed. So I say colon curly brace data dot. There is a built-in function in enumerable that is count. So it tells me how many elements are there. Then I say int sum equals to 0. I want to do a sum total of each of the numbers. Here I go for each. I can use var n for number in the collection that is data. Sum plus equals to n, which means sum is equals to sum plus n, right? Finally, I say console.writeLine interpolated string displays the total is brace sum. quite straightforward thing, nothing special about it. Just couple of things might seem new here, like the use of enumerable and enumerable. Rest of the things is quite straightforward, something based on what we already know and have used in one way or the other. Yes or no?
Yes. Yes.
Let's start this. Just watch the sequence, how the output comes in. Invoking get numbers list. There was a long pause in between, around 10 seconds, right? Get numbers list finished. Number of values in the collection 10,000. The total is 5,000,5,000. Okay. Now I'm going to make some changes here. I want to use the task parallel library here. So apart from system.threading, I'm going to have another namespace invoked, system.threading.tasks, which represents task parallel library. Okay. Done.
Yes, sir.
Now focus on this function. I'm calling get data here. This is like one by one, the numbers are going to be generated. 1, 2, 3, 4, 5, and so on. Okay. Now, again, this is like one person doing all the job. That's why sequence is followed. 1, 2, 3, 4, and on. Correct? Suppose if I say there are 4 or 8 people doing this, each person is going to give me a set of numbers. What do you think? The number generation will happen quickly, or it will take more time than the single person generating 10,000 numbers? The numbers may be sequential, the numbers may be random based on the need. But in either case, tell me, what will be the scenario? Single person generating 10,000 numbers is fast, or 4 or 8 people generating 10,000 numbers in total is fast? Tell me quickly. Easy question it is.
Many doing together is faster.
Because they won't be targeting 10,000 number individually, right?
Yeah.
Ideal situation is like everyone divides the job equally. But in reality, it may not be possible, because if I have 8 people, they might have their other work also going on, right? But still, it is going to be faster as the contribution from multiple people will come in, right? Everyone will commit. Okay, I'll give you 2,000 numbers. I'll give you 1,500. I'll give you 2,500. So with this kind of contribution, the time taken to generate total 10,000 numbers will be less. What's my point? What is happening here? It's basically a single person doing the job, right? So how do I make it in such a way that if number of processors available are more than one, use them depending on their availability? First thing I do is here I say that this function is going to be an asynchronous function. An asynchronous function is supposed to return a task always. What is task? An high level hybrid of thread, which basically knows that if the task can be distributed across multiple threads, let's break it down and distribute. Thread, on the other hand, is just one single thread, path of execution. Task itself can be broken down into number of threads. It's a high level entity. Understood? So when I return task, basically task is something which lets me have some kind of handle in my hands using which I can check whether the job is completed or it's still running. Maybe one of the contributor is not done. Maybe all the contributors are not done, they're still working. How do I keep track of this? That's where the task comes in. Something like a supervisor. Understood?
Yes.
Now, with this, the C# naming convention says that any method which is actually an asynchronous method returning a task should have a name that ends with async. So that anyone can understand this is not the synchronous method. This is asynchronous method which can be divided in different threads as well if required. Understood? So that the calling can be done accordingly. We don't need to go through the documentation. Got it? Got it?
Yes.
Here the return statement also changes. It cannot return get data directly. It has to run get data on multiple threads based on availability, and basically it cannot return the data coming out from different threads separately. It rather needs to have a supervisor controlling all those threads, and the instance of that supervisor needs to be returned. So that's where it has to return a task. So we say return task. Task provides us a method, static method called as run, which takes a delegate named as action or maybe a function. I am more interested in this func. Action is something which basically talks about running some method that doesn't return anything, void methods. Func is something that returns me something. Now get data is returning me something, right? So that's why I'm going for func. It's a delegate. Say I'm looking for a new func instance of type enumerable of int, which means the return type of that function should be an int. And then here I pass the reference of the function which matches with the signature of that func. Let us get data. Okay. Still there is an error. Reason when I'm returning a task, I cannot just return it this way. Run is giving a task. It has to be something which needs to be awaited, so that the supervisor instance goes back. It doesn't mean that function is finished. The underlying function is finished. It may be still going on, but the supervisor handle goes back immediately. This is asynchronous. So basically, this doesn't block my action. The main method which calls this get numbers list async method will not get blocked. It will be able to do something. Meanwhile, this function will keep on doing its job on a separate thread or set of threads. That's where the async programming comes in. Understood? So one example usually I take over here from our live experience. What I'm delivering right now is a training program, correct?
Yes.
What you guys think, whether it's a internal program, means I'm from Providence, or I'm
No,
an outsider.
outsider.
Outsider means I must be a vendor, correct?
Hmm.
Now, what do you think? Is it a charity program or I'm doing it for some commercial part?
Commercial.
Commercial, because this training is actually a kind of a consulting, right?
Yeah.
And that's my bread and butter, which means it's a commercial program, correct?
Yeah.
Like once you get trained, you will be working on some applications against which, I mean, against your work, you will be getting paid. Maybe that is where the salary comes in, correct? So there is a commercial angle there as well, correct?
Yes.
Now, again, coming back to the original thing, I am doing a commercial program. What does it mean? Once the training is over, I have to raise a bill and against which I'll be paid. Yes.
Yeah.
So do you think when the B2B, that is business to business transactions are happening, the commercials are like the moment the program is done and bill is raised, immediately the payment is done?
No.
Like when you go to mall and purchase something, you have to pay it then and there itself. Is it like that?
No.
That is something which is applicable to B2C, business to customer, right?
Hmm.
In case of B2B, the relationship is different. It's a long relationship, correct?
Yeah.
I'll be working for years. As far as I'm doing good job, my company is doing good job for you, I will keep on continuing, right?
Yes.
Okay. So that's where something called as credit period comes in. What does that mean? I raise the bill the moment the training is over, right? But the payment terms will be like, okay, 15 days, 30 days after receiving the invoice. Invoice is reached, it is logged into your system. Someone has to actually verify that invoice, approve that invoice, then it goes to finance. Finance has to approve that, and then the payment is disbursed. Am I right? And so many verifications and approvals are there. So basically, it is going to take time, and that is why the credit period is there in between. Yes or no? Yes or no?
Yes.
It must be something similar in case if you submit some reimbursement forms, correct? Whatever reimbursement you have claimed, your documents will be scrutinized, and based on that, the disbursal will happen. So it is not immediate, right? It takes some time, correct?
Yes.
Now, does that mean when I actually raise the bill, suppose this training is happening in premises of the Providence office, my training is finished on last day, I receive the, I mean, I raise the invoice and I just keep on waiting till I don't receive the check. Now, it may be 10 minutes, it may be 10 days, it may be 1 month also. Is it going to be practical for me to keep on waiting there?
No, no.
If I do that, I would be losing my precious time, right? Because once I get free from one training assignment, I can get into another training assignment. Yes or no?
Yes.
Okay. So I cannot wait, right? But then someone basically needs to track whether the payment is received for this assignment or not. Correct? There is a separate
Yes.
resource in my company who will be assigned this task, who has the responsibility to talk to the concerned person and get the update about whether the payment is done or not. If not, when it will be done. Or if it is stuck for some reason, what is that reason? So that we can supply with the resolution, right?
Yes.
I will not keep on waiting. I'll just move on. I'll carry on my other actions, right? And in between, if some escalation is there that, okay, this topic we need to cover again or something, or maybe we need more in-depth coverage on this, please conduct one more day of training, and then we will release this payment, maybe with some additional charges also. Then only I'll come into picture. Am I right? This is what we call as asynchronous behavior. If I keep on waiting till the time the check is not released, that is synchronous behavior. I have a dependency. Understand?
Yeah.
Okay. More easier solution would be like, say, your laptop develops some snag and it's not working. It's not simply booting up, or it boots up and then hangs. One way is give it for repair and keep on waiting. It may take 7 days, 8 days, 10 days. Keep on waiting and don't do anything. What is this behavior? Synchronous. When I get the laptop back, I'll start. Till that time, I cannot do anything. Other way around is I get a replacement laptop or maybe standby laptop. I start doing my work on it. And when I receive my one, I just transfer the work over there. So now in this situation, whether that laptop takes 2 days or 20 days or 2 years, I don't care, because my work is not hampering. Correct?
Yeah.
That is asynchronous behavior. Understand? One more example I have. I hope everyone must be using Amazon and Flipkart or both. When you order, do you immediately get the order after making payment? Here you make the payment and there someone is standing at your door carrying your item? No. You place the order, you make the payment, and then it takes 1 to 2 days to a week also at some time, depending on which item you have purchased, and then you get it. Now here, Amazon or Flipkart are not selling anything. They are just facilitators, right? They're allowing you on their portal to place an order. The actual order fulfillment is done by their partners who have their own applications using which they pull in the orders that are received for them by Amazon. They check the payment status and all, and then they actually start the shipping job, packaging and shipping, right?
Yeah.
What is this behavior? This is asynchronous behavior, right? At any point in time, you can go and track what is the update, whether the product is shipped or not, or yet to be shipped. So you can see a tracker there on both the portals. Yes or no?
Yep.
Probably for cheaper and smaller things, we don't actually like to track. But if there is some costly and important item that we have ordered, say for example, I have ordered a laptop, I would like to track. Am I right? This is possible only with the supervisor object in my hand, like task. Going in between and checking whether, I mean, what is the status? What's going on? Understand? Yes or no? I assume it is yes. Now here there are few things which are going to change. Because it is asynchronous operation, I'm not going to get the data directly. I'm going to get a supervisor object. So here I say it is the T object which will capture that supervisor, which is nothing but a task. So here I say var T equals to m dot get numbers list async. Now with this supervisor, I can keep tracking whether it is completed or not. So I go for a while loop within which I put the condition as while not T dot is completed, means it's not yet completed. Show the progress. Console dot write single character dot. I want this to be done every 300 milliseconds. If I want every second, I'll pass 1000 there. And then once I come out of this loop, that means the T dot is completed property must be returning true. Means the operation is completed. I can receive that result here by saying var data equals to T dot result. Supervisor says that, okay, my result is in the property called as result. Understood? Let's start the program here and see if we get some different behavior here. Invoking get numbers list, dot, 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 dot going on. And there the result comes in. This looked better, right? This dot was possible because I was able to continue even before this method returns me the final result. If this method is not asynchronous method, in that case, my while loop will never run until and unless this method is not returned. It will keep on waiting for it. That becomes synchronous. So previous call actually was synchronous. Do you get it? Yes or no?
Yes, sir.
Now, here 10,000 numbers being sum total. Let's say there is a thread dot sleep here as well. Assuming that it's taking some time, maybe a delay of 200 milliseconds I introduce here. Every number, every iteration takes 200 milliseconds, let's say. Let's start this and see. Till that dot dot dot, it's okay. That's the same thing. I'm more interested in the sum total being displayed, how soon or how late it displays. Number of values in collection, that count is come. Now see here, there is a blockage. See that 200 millisecond delay itself is so big. Reason one person right now is doing the sum total, one processor core only. And each iteration is taking 200 milliseconds at least to finish its job. It's going to be huge actually, because there are total 10,000 numbers. These many seconds will be required to finish the job. Even if I say convert it to minutes, 33 minutes point 33.33 minutes means more than half an hour will be required to finish this. Don't you think waiting for half an hour just for looking at the total of the numbers is irritating? Realistically, if one person is doing the sum total, it's going to take time. Yes or no? Yes or no? Tell me
Yes.
quickly. So, can we do something about it? Let me comment this. We do have another class provided by TPL, that is parallel. If dot for each. This is parallel version of for each iteration construct only. Again, read only. Takes in the first parameter, which is going to be the collection on which I need to operate on. So our collection is there in data, comma, the delegate action needs to be passed over here, which will be doing the real processing, the actual algorithm. So here I say that delegate takes in a parameter n. I use lambda expression over here. Lambda expression requires a method body here. So between, I say thread dot sleep 200 milliseconds, followed by sum plus equal to n. Logic is still the same, just that instead of sequential for each, now I'm using a parallel version of for each. This parallel class is written in such a way that it is designed for working on multiple processor cores or multiple processors, or maybe the combination of both. I may have multiple multi-core processors. With modern servers, that's the case. Understand? Now, in this case, we cannot predict how long it will take. It may still take 33.33 seconds. Though I have 8 logical cores, it is quite possible that 7 of the cores might be busy in something else. That is quite possible with server operating systems, right? Server machines. But if any one of the core from those 7 cores become available in between, the remaining job can be further distributed, right? So I may get a better performance as well. Let's see. Initial part anyways is not having any issue. Interesting part starts now. Number of values in the collection, 10,000. Let's see how long it takes. Earlier we waited for around 4 to 5 minutes, right?
Yes.
This time it will not be that much. Probably we'll get the solution pretty quickly, depending on the availability of my processor cores. So sometime back before the break, we saw in the task manager, my machine is having 16 logical cores. And here is the availability also. See, the result came in pretty quickly this time. I believe we waited much more than this much amount of time in previous case. Yes or no?
Yes.
So understood the importance of TPL? Yes.
Sir, could you explain the for each property?
You understand this for each?
I understood that it's a read-only construct that it can only
It
read the.
it is as good as for int I equals to 0, I less than the length of the collection. Okay,
Oh,
and then just reading the value from each index and processing it.
acha, okay.
So instead of using index, I am reading the actual element directly. I'm going to the memory location directly. Understand?
By
So
use.
it becomes, yeah. And see, with for loop, what happens is when I say for I is equals to 0, I less than length of the collection I plus plus, uh, let's say it is the same thing, sum plus equals to ARR of say I. Now, when I say ARR of I, where I is 0, I'm reading ARR of 0.
Hmm.
I, while I'm processing this ARR of 0, I don't keep ARR of 1 ready for the processing, right?
Yeah.
Once my cycle is over, then I say go next. Means ARR of 1. Now you locate, now you bring in, and then process. So locate and bring. Don't you think will take time?
Yeah.
Let's get back to that passport thing that we discussed. For loop, if we are employing, let's say there is a building and the queue is at the outside of the building. Okay, the room is on the third floor where that document submission is happening. Okay, now first candidate called upon. There is a loudspeaker outside. The person collecting document says, okay, candidate, please. First candidate from the queue goes. Okay, the document submission happens. Now loudspeaker is not going to be used. What this officer says to this candidate while going out, ask the next person to come in. So he'll go all the way back to the exit and will tell the next person, now you can go. This person will walk in and reach the third floor. On the third floor, the room he will locate and reach. What do you think? Will be wastage of time or not?
Yes.
For loop works that way.
Okay.
On the other hand, what for each does is similar stuff, but when the loudspeaker announcement is there for the first candidate, it's not just one candidate which will start moving. There will be two candidates that will start moving. The first one will directly go inside the cabin. The second one will wait outside the cabin. Understand?
Yeah.
Now, first one is done with his submission. This officer once again will say, while going out, send next. Okay. So send next means not the one who is waiting outside the room. Okay. Send next means the third one. Meanwhile, the second person will get into the room. And the first person, while going out via exit, will ask the third candidate to go and wait outside the room.
Yeah.
What do you think? What is more efficient?
The second method.
Second method. And that's what for each does.
Okay. And one more thing, like you put the lambda expression
Yes.
for like calling it back, but you did not declare a delegate like function or
That
method.
is, yeah, correct. In this case, what is happening? The for each method itself is already using a built-in delegate provided by the system. So if you have noticed, here it was asking for action. What is action? It's a delegate only built into the system. I didn't create. System already has it.
For each in the for each function, like
Yes, not in
variable.
for each. Action is
By
a delegate in the framework, which can be used by anyone. And by that, for each is also using it for its own purpose.
okay. So for anything you don't need to declare it if you're
If it is already there, I don't need to declare.
okay. Okay. All right.
Yeah, if I'm looking for some delegate which is not there in the system or anything similar to that not there in the system, then I need to create my own delegate.
Okay.
Understand?
Hmm.
So this for each is doing exactly same thing like this, but for each was going one by one. Take number one, add it to some, right? Take one number, wait 200 milliseconds, then add it to some. Then take another number, wait another 200 milliseconds, add it to the sum. Take third number, wait 200 milliseconds, add it to the sum. And this is going to keep on happening till all 10,000 values are not processed. Which means 200 multiplied by 10,000 number of milliseconds. That's what I was doing in the calci. 200 milliseconds per number. How many numbers we have? 10,000. So multiplied by 10,000. These many milliseconds required for the complete process to finish. Convert it to seconds. So divide by 1000 is 2000 seconds. Convert it to minutes. Divide by 60. These many minutes. With parallel processing, did it took so much of time?
No.
I believe just under 2 to 3 minutes it finished. Yes or no? Reason?
Hmm.
The most optimized version would be 8 processor cores are there. As per the utilization graph that was shown in Task Manager, I can say all 8 were used by my program because none of them was 100% utilized anytime, right? All of them had free time. That means all of them are used. So 8 numbers got picked up at once. Waited for 200 milliseconds, added to sum. Next bunch of 8 numbers. So every cycle was processing 8 numbers in this case. And hence the overall time taken was quite less. So simple calculation if I do, how many cycles were there? 8 numbers at a time. So total cycles, if I say 10,000 divided by 8, these many cycles were there. multiplied by 200 milliseconds. These many milliseconds. Divide by 1000. These many seconds. Divide by 60. These many minutes. The rough calculation says for just a little bit over 4 seconds, 4 minutes. That might be something near to it. But still, 33 minutes to 4 minutes. Is there a difference, sizable difference in the time taken to process the same thing or not? What do you think?
Yes.
Right? This is a rough estimation. This is not final calculation. I'm going with the ideal situation where all processor cores are assumed to be available all the time. Then this is what I would be having. Yes or no?
Yes.
So I'm now utilizing my powerful processor well over here. Yes or no?
Yes.
Previous code was not utilizing the entire power. It was just utilizing one core. Correct? Now, can I use this parallel processing everywhere? No. In some cases where the sequence of the code execution has to be maintained because there is a dependency of logic on the previous logic, then you have to go sequential way only. But wherever you feel that, okay, these tasks can be done asynchronously, independent of each other, that's where the parallel processing can be used. Do you get it?
Yeah.
One more example I'll show you, which will give even more better idea to you about the parallel stuff, especially the parallel class. So let's take another console application, file new project, and then console application. Next, name this as demo parallelism. Set your location right. Next, .NET 5, create. Some namespaces we will import here. To start with system.threading. Later on, I'm going to need system.threading.task also for parallel processing. So let's keep it ready. I'm also going to need one more namespace here. That is system.diagnostics. One utility class I'm going to use from here, that is stopwatch class. By name, it must be clear what it must be doing. Stopwatch, typical stopwatch. Delete this, and in class program, I create a helper method, static void. I didn't provide access modifier, so it is by default private. Is simulate processing. This is just like that get data function. This is going to do some dummy operations for me. So basically, it will occupy the processor time for given number of, I would say, cycles. Here I say thread.spin weight. Eight with 7 zeros along with it. These many empty CPU cycles will be caused. That means whenever this method is called, it will go into the processor these many number of times. Processor means processor core total. Okay. I create Another helper method, static void, sequential, or something what you can call as non-parallel method, conventional. It uses normal for loop. For int I equals to 0, I less than, let's say 16, I plus plus, console.writeLine, an interpolated string, which actually is going to display me a thread ID, basically the ID of the thread on which the code is running, which I can get with the help of the thread class. Thread dot current thread dot manage thread ID. Along with this thread ID, I want to display the value of I also. I is equals to curly brace I. And then with
So why
each,
didn't you directly use for each over here?
see, for each requires some collection to work upon, array or collection. Do we have any array or collection here? I
No.
just want iteration for given number of times. So by this logic, I can say I'm looking for some 16 iterations, which are not based on any collection or array. Just 16 iterations I need, right?
Okay.
Yeah. If I have array or collection, ideally I should use for each. Understood?
Yes, sir.
Okay. And then with each iteration, I want these many empty CPU cycles to be carried out. Probably this will be done in one CPU cycle, and then these many empty CPU cycles. So that without using thread.sleep, I still see that, okay, this is a time consuming operation. A big complex logic is there, which is taking a lot of time to finish. Understood? Again, in real-time programs, there is no space for this. If you are communicating with some server which is there in US, probably by default, it will take that much of time. Or you may have so huge amount of data that it will by default require these many CPU cycles or even more number of CPU cycles, right?
Yes.
Now, one question I expected here, what is CPU cycle? CPU cycle means how many times my code is running inside a CPU. With time slicing or round robin, you get a specific amount of time to get inside processor and do your job. Whether you are done or not, you have to come out after that time and then wait for the next turn, right?
Yes.
Right? Okay, so that's what CPU cycle is. Now let's get to main. And here what I'm going to do is, first of all, display the main thread ID from the main method itself. So I put a interpolated string which says display main thread ID, and there I say thread dot current thread dot manage thread ID. Then I create the instance of stopwatch. SW equals to new stopwatch. Instead of actually saying new stopwatch, I would rather say stopwatch dot start new. It will not only create the new stopwatch instance, but start it as well directly. And then here I make a call to that method, sequential method. And once it is completed, here immediately I say SW dot stop. With this, I can find out how many milliseconds actually were required to finish this sequential method processing. Right? Which I display here with an interpolated string. I say it took SW dot milliseconds, elapsed milliseconds is MS over here. console.write line one more time with a slash in. Here I say finished job. And that's it. Okay.
Sir, you
Pretty
intro-
straightforward stuff. Yeah.
you introduced many terms, like current thread dot managed thread together. Then there is no method as stopwatch, but you created an object, class as stopwatch, but you created an object. Could you explain that?
See, I believe new terms start from here, right?
Yeah.
Spin weight is like empty CPU cycles being brought in. These many number of times I'll go inside the processor and come back. I won't be doing anything in it, but I occupy the processor time. Understood? Like I go to consultant, I don't ask him anything, but yes, I got half an hour 3 times a day for next 7 days. I'll be just occupying his time. And when I go inside to talk to that consultant, no one outside knows that whether I'm doing something or not. Correct?
Yeah.
So this is just like that. Next new term maybe somewhere here, right?
Yes.
A code runs within a processor as a part of a thread. Thread is nothing but path of execution. Normal piece of code, 2-3 lines of code, if you have how it runs, top to bottom, right?
Yeah.
So if you draw a straight line, it just looks like a thread, isn't it?
Yeah.
Okay, so that is thread. Thread.current thread means what? The thread on which the current code is running. Understood?
Mm-hmm.
And what is thread ID? Thread ID is nothing but the ID assigned by operating system to that particular thread.
So it's not
Every
just
thread will have
ID,
a unique ID.
it's managed thread ID. Like it's not just ID. Thread ID.
Managed thread ID is because CLR is managing that in addition to OS. So that is just a term. Actually, it is thread ID only.
Okay.
Thread ID not managed by OS here. It is managed by CLR. That's why managed thread ID.
Okay.
Typically, it is thread ID. So there is a unique ID assigned to each thread so that the system can keep track of on which thread what kind of code has been allotted the time. Like you get token numbers, right?
Yeah.
And then based on token number, it is advised go to that window, go to that window. Correct?
Yes.
Now window is thread, and your token is actually your nothing but the thread ID, I would say. Understood? Window
Yes.
number is rather thread ID. Your token is your ID. Okay, job ID.
Okay.
Now the next new term probably is stopwatch. In real life, what is stopwatch? It is the same thing here.
Okay.
In a race, usually stopwatch is used, right?
Yeah.
So when the race starts, the stopwatch starts. When the race ends, the stopwatch is stopped. Correct?
Hmm.
It's the same thing here. So using this, we are actually checking how long the method is taking to complete its processing. It may be 1 millisecond, 1000 millisecond, or maybe less or more. Yes,
Okay.
that's it. The stopwatch object gives me the number of milliseconds taken to process this method over here with elapsed millisecond property. Got it?
Yes.
Let's start the program and watch the on-screen things. It says main thread ID is 1. And then the call to sequential method is there. Sequential method is having some code that displays thread ID again. It is showing the same thread ID as main. What does it mean? It simply means that my code is running on the same thread. I mean, the code within the sequential method also is running on the same thread as that of the main, which means my main method is getting blocked until and unless sequential method is not completed, my main thread is blocked. Yes. All through you can see the thread ID is 1111111. It's not changed. Yes or no? Also, the value of I, if you notice, it is quite sequential. 0, 1, 2, 3, 4, and so on goes up to 14, 15 at the end. Yes? How long it has taken? Just to complete 16 cycles or 16 iterations, it took 43,326 milliseconds. Can I say 43 seconds? Yes or
Yes.
no? Now, let's see the parallel version here. This I'll copy. Here I create another method so that you can have comparison anytime. Let's say it is named as parallel method. What parallel method contains is the parallel version of the for loop. Just like parallel contains parallel version of for each, parallel class contains parallel version of for also. It's a parallel.for. First value is from where it needs to start the iteration, begin value. This is equivalent to I equals to 0. Next parameter is end value exclusive. If I'm looking for 16 cycles, I have to say 16. So it is actually less than 16 only. Comma, the action, the delegate. Delegate that takes in the parameter of type integer, I. And here goes the lambda expression body, which I arrange on multiple lines like this. And then here I paste the code which I copy. The same 2 lines copied from here. Like this. Exactly same code. The logic is not changed. And then one simple change I'm going to do here. Instead of sequential method, now I'll call parallel. Should be A. There was a typo, so sorry for that. It's corrected now. So technically, nothing changed here. I could have changed this logic right within this method itself, right? So whatever is changed is this. Instead of sequential for, I have a parallel for. Logic is quite the same, the load is quite the same, and I start. Watch it, how quickly the output is coming. What's the thread IDs? Main thread ID is 1. None of the threads over here show thread ID 1. They have different thread IDs. 4. Okay, 1 is also used here. Then 5, 6, 7, 8, 9, 10, 11, 8, 5, 9, 11, 4, 10, 6. There is some reuse also of the threads. And then the value of I you can see is non-sequential. But if you closely watch, each and every value has been generated. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All are there. Total 16 iterations are there. And how long it took? Earlier it was 43 seconds. Here it is just over 8 seconds. Same logic, same load, same amount of work, but this has worked quite fast. Reason? My logic was distributed on multiple processor cores. Contribution from around 8 processor cores. That made the overall time consumed less over here. Understood? Understood? It may not be always the same. It may vary a bit here and there. Sometimes it may further improve. Sometimes it may degrade as well in terms of performance. But that all depends on the processor core state at that moment of time. We have already discussed that, right? Here you can see around 300 milliseconds more has been taken. Run it again and let's see this time how long it takes. Depends on the state of the processor core. Understood? Yes.
Yes, sir.
I give you 2 minutes, just go through it and see if you have any questions.
So just one small question, like 16 is the number of iterations the task is being processed. Eight
Correct.
thousand 8,000 is the number of, like, it's how many times is the thread is going into the CPU, like,
GPU,
or
right. How
okay.
many cycles are being used? This has nothing to do with the iterations. This is CPU occupancy.
Okay. So for each iteration, 80,000 or whatever the number is.
Yes, yes, exactly. That's right, Urmil.
Okay, okay.
Now the thing is the processors are so fast that we don't realize that this big number of times actually the CPU is getting into action for our job, right? If you run the same code on an older PC with some, Pentium 1 or Pentium 2 processor, you will actually notice that yes, it's something time consuming. Understand?
Yeah.
And think of the first generation CPUs like 8086. Hardly few kilohertz was the speed. These days we have gigahertz of speed. So just imagine. Parallel programming would have helped that time also, but see the amount of data at that point in time, amount of parallel operations that point in time were not that huge. Data has grown over the years, and that's where people wanted to find out the ways how to utilize limited number of resources in more optimized way. Understand? without causing any damage to the system. Understand?
Yes, yes, sir.
Isn't it interesting?
Yes.
Okay, so we'll take a break over here because the topic is going to change here. And let's say we resume at 405, where we'll be talking about the database stuff, entity framework precisely. Okay,
Yes, sir.
so see you then at 405.